Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in today's class, what we are going to do is that we are going to discuss how sound propagates in air, specifically in air. And we will see that as we have discussed in the previous class about the types of waves, in that we have seen that there are two kinds of mechanical waves. One is longitudinal wave and another one is the transverse wave. And when sound propagates through air, basically it travels in the form of longitudinal wave. Okay, how? So let us just discuss. It's that needs to be that you should have some sort of imaginative power to understand this, because we are not able to show you by the 3D diagram. We'll try to make the process simple so that you can understand without seeing the 3D explanation. Okay, so just imagine when you are discussing about this process. Okay, so sound propagation. Okay, so propagation, make the meaning, propagation of sound in air, propagation of sound in air, right? Okay. So how does sound propagates in air? Let us understand this process. Okay, so sound in air propagates. When sound propagates through the air, the particles of the air vibrate in a direction which is parallel to the direction of the motion of the wave or the motion of the sound. Okay, so just let us try to imagine that if we have a scale, a thin plate, the thin scale that you have with you, steel scales, okay, the thin scale like that or the thin plate like this you have with you, okay, and this is just put into a rigid support, okay, put into a rigid support. Now when this plate is pulled, okay, and released, as it is thin plate, steel plate, okay, when it is pulled and released, what it happens, it vibrates to and fro, isn't it? It vibrates to and fro. So suppose, consider that you place this plate on the left hand side and you release it. What will happen? Definitely this plate will keep on vibrating left, right, left, right, left, right like this, okay, and it will be quite fast. Now think, when you pull the plate towards the left and released it, the plate first of all from its mean position just moves in this fashion and comes to this position. We are analyzing the process very slowly, okay, comes into this position, fine. Now when the plate comes into this position, what happens? The air particles surrounding this region, that is this region, okay, what happens? The air particles here get compressed. Why? Because the plate has shifted its position from its mean position to the right, and now the air particles here get compressed, okay. And if you just consider the another air layer just beside this air layer, then that air layer will seem to be in a relaxed zone. It will be in a relaxed zone. There will be a relaxed zone like this, okay. They are far away from each other. This is the region where they are not close to each other, not compactly, okay. Now when the scale, what happens, when the thin plate of the scale, whatever you say, comes back to its mean position and then moves back, what happens? Then moves back. So this is position number 1, then it moves back like this, okay. So it now goes to a position like that, in similar to right, but in the left side, okay. This is position number 2, okay. So when it moves to position number 2, what happens here? The air layers just here, now again these air layers get compressed. Previously they were just relaxed, and the air layers just beside these are still in the relaxed, okay, relaxed. So they are relaxed, okay, fine. Now what happens when the air particles get compressed, okay, like this region or this region? This region is called the region of compression. Okay. Now when the plate has moved from this position to this position, position number 2, what happens? The particles when the scale on position 1 were compressed, now these particles get enough space to relax themselves and they pass on the additional energy to the air molecules just beside them. So when the scale moves from position 1 to position 2, what happens? When the scale has moved from position 1 to position 2, now this region becomes the region where the air particles will get relaxed. Okay, and when these air particles get relaxed, what happens? They actually compress the air particles just beside that. So here the air particles are now getting compressed like this. Okay, now getting compressed like this. So what happens? The region which was just a few moments ago was in the compressed zone now becomes the relaxed zone, and the air particles just beside those, the air layer just beside that region now becomes compressed. Okay, so what happens? There is an alternate region of compression and rarefaction, isn't it? Compression and rarefaction. Now when the scale again comes back to position number 1, okay, or its mean position, the air layers here again they start relaxing, and when the scale once again reaches this from this position 2 to again this position, okay, again this position, now I can consider this to be position 3. Okay, then what happens? Then the air particles in this region again get compressed. Okay, so this region is again compressed. Now these air particles here get again compressed. Okay, so they again get compressed here, and the air particles which are marked in green will now become relaxed because they have already passed on the excess energy. Okay, what is disturbance? Disturbance is an excess amount of energy which is being just transformed from another form into that region. Okay, so this region again becomes rarefied, that is the region of rarefaction, and the region beside that again become compressed. Here this layer of air become again compressed like this. Okay, so this is the case when the plate moves from position 2 to position 3 once again. Now again when the scale moves to position 3, the air layers here they become relaxed. So this again creates a zone of rarefaction like this. Okay, and what happens? This layer, the sideways, this layer beside this side, they again get compressed. Okay, they again get compressed. So you can see there is alternately a zone of compression and rarefaction, Okay, so in this way the sound, the excess, the energy that is being created, not created, it is being transformed from other form to the sound energy. That excess energy gets transferred from one particle to another particle. Okay, so alternately you can see there is a region of compression, then rarefaction, then again compression, then again there will be rarefaction, then like this the sound moves on. Okay, so basically what is happening, the particles are moving to and fro in this direction like this. Okay, and in which direction do you think the sound is traveling? The sound is traveling in this direction. The sound is traveling in this direction and the particles are vibrating in this direction. So can you imagine that yes, the particles are vibrating in a direction parallel to the propagation of sound, or at least you can say also parallel as well as anti-parallel to the direction of the propagation of sound, but they are actually moving in the direction of the propagation of the sound, isn't it? So this kind of way by which the sound can travel through air, creating regions of compression and rarefactions, alternate regions of compression and rarefactions, are called the longitudinal wave. So I hope you have this propagation of sound. Okay, the propagation of sound in air through the formation of compression and rarefaction is clear. Okay, now think that when you have said that what are the prerequisites for a medium to so that sound can travel through it, we have said that medium must be elastic in nature. Why? Because if the medium is not elastic, the particles will not come back to their original position. So when the scale moves from position from this extreme right position to the extreme left position, and then again moves to the extreme right position, if the particles are not elastic, they will not come back to their original position, and they will not, and when the screen plate again moves to the extreme right position, it will not get any particle to transfer the excess energy. Okay, so that is why the medium particles must be elastic, otherwise the particles will have a permanent shift from their position. And as we have said that while sound propagates through air, the medium particles do not actually travel. It is the excess energy that is traveling from one particle to another particle. The medium particle remains in their position, corresponding position. So in this way, sound basically travels. Okay. So for the medium to carry the sound, the medium particles must be elastic. Otherwise, the particles will not come back to their original position and they will not be able to carry the sound. Once they will just carry the sound for once, not again repeatedly. They will not do this process. They will not go through this process. Okay. So this is why the elastic nature of the medium is very important for the propagation of sound. Okay. So I hope the propagation of sound through formation of compression and rarefaction is clear. Okay. Fine. So in the next class we will be discussing some terms related to the propagation of sound, as we can also say propagation of wave. In today's class we will end the class today here. Okay, please do study well. If you have any query, do mention it in the comment box. We will be happy to solve your problem. Okay, so till the next video, tada, goodbye.